Hello my dear friends. Today class, welcome to my channel Teacher at Home. Today class we are going to learn the 14th chapter, that is electric current and its effect. You might have tried the game. How steady is your hand? If not, you may try it now. Paheli and Bujo had also set up the game by connecting the electric circuit, just discussed in class 6. They had lots of fun trying it out with the families and friends. They enjoyed it so much that they decided to suggest it to a cousin of theirs who stayed in a different town. So Paheli made a neat drawing showing how the various electric equipments components were to be connected. See here what is showing: a key, battery, two nails, and a connector. Can you draw the circuit conveniently? It made Bonjo wonder if there was an easier way to represent the electric circuits. So if you know any other method, please draw and show. Symbols of electric components. What are they? Some common electric components can be represented by symbols. Some electric components and their symbols are shown. You may come across different symbols for these components in different books. However, in this book, we shall be using the symbols shown there. So, in order to represent certain circuits, we use symbols. Look at the symbols carefully. In the symbol for the electric cell, notice that there is a larger line and a shorter but thicker parallel line. Do you recall that an electric cell has a positive terminal and a negative terminal? In the symbol of the electric cell, the longer line represents the positive one and the shorter one represents the negative terminal. So, the connection of a battery can be written as a positive means a longer line and negative means a shorter line. For a switch, the on position and off position are represented by the symbols as shown. The wires used to connect the various components in the circuit are represented by lines. Battery or symbol are also shown. Do you know what a battery is? Look at the symbol of a battery. Can you make out what a battery could be? For some of the activities we may need more than one cell. So we connect two or more cells together. Notice that many devices that the positive terminal of one cell it is connected to the negative terminal. Such a combination of two cells it is known as battery. In this picture we can see many components. That is, first one is electric component is electric cell. In the cell we can see a positive and a negative terminal. The long line is a positive and short one is a negative. Electric bulb can be represented as this glowing one. This is on position. Two are connected. Off means two are not connected. Battery. It is two lines connected. Positive and negative. And a wire it is shown. Many devices such as torch, transistors, toys, TV, remote controls use batteries. However, in some of these devices, the electric cells are not always placed one after the other. Sometimes the cells are placed side by side. Then how are the terminals of the cells connected? Look carefully inside the battery compartment of any other device. There is usually a thick wire of a metal strip connecting the positive terminal of one cell to the negative terminal of the other cell. In order to help you to place the cell correctly in the battery compartment, plus and minus symbols are usually printed there. How can we connect the cells to prepare batteries for our activities? You make a cell holder as shown in using a wooden block, the two iron strips and rubber bands. It is necessary. So iron strip and a rubber band, it is necessary to hold the battery together. Then the rubber band hold the metal strips tightly. You could also buy cell holders from the market for making batteries. Making batteries or two or more electric cells. Place the cells in them properly such that the positive terminal of one cell is connected to the negative terminal of the next cell. Connect a piece of wire each of the two metal strips of the cell holder. A symbol used for representing a battery is shown. Let us draw a circuit diagram, electric circuit using the symbols. Haley and Bojo wondered whether the batteries used in tractors, trucks and inverters are also made from cells. Then why it is called a battery? Can you help them to find the answer of this question? Used for representing a battery, that is, make the electric circuit shown here. You used a similar circuit in class 6 to make electric bulb glow. Do you remember that the bulb glows only when the switch is in on position and glows only when the switch is moved on the on position? Copy this electric circuit in your notebook. Make also a circuit diagram of the circuit using symbols for the various electric equipments. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram. Recall that the bulb glows only when the switch is in on position and the electric circuit is closed. That is, when the bulb glows, it will be in the on position. See here, an electric circuit it is shown. The bulb glows when they are connected together. Here the symbol representing the bulb. Notice that the key or switch can be placed anywhere in the circuit. When the switch is in on position, the circuit from the battery, positive terminal of the battery to the negative terminal is complete. The circuit is then said to be closed and the current flows throughout the circuit instantly. When the circuit is in the off position, the circuit is incomplete. It is said to be open. That is, when it is incomplete, it is said to be open. No electric current flows any part of the circuit. In the bulb, there is a thin wire that is called the filament, which glows when an electric circuit passes through it. When the electric bulb gets fused, this filament it is broken. That is, when it is fused, it gets broken. Never touch a lighted electric bulb connected to the mains. It may be very hot and your hand may get burned badly. Do not experiment with the electric supply from the mains or from the generator. So you should not play with the electric current or never touch a glowing bulb. Okay, it seems whether on or off. See, when it is on, very hot will be there and our hand get burned badly. Okay. Use only electric cells for the activity suggested here. If the filament of the bulb is broken, would the circuit be complete? Would the bulb still glow? Only when the filament get connected, the bulb glows. Otherwise, it may not glow. Heating effect of electric current. Take an electric cell, bulb and a switch and a connecting wire. Make an electric circuit as shown. This activity has to be done using only one cell. Keep the switch in the off position. Does the bulb glow? Touch the bulb. Now move the electric switches in the on position and let the bulb glow for a minute or so. Again touch the bulb. Do you feel any difference? After moving the switch back to the off position, touch the bulb again. Make a circuit as shown in the figure and about 10 cm long piece of nichrome wire and tie it between the nails. You get nichrome wire from an electric repair shop. Touch the bulb. Now move the electric switch in the on position and let the bulb glow for a minute. Touch the bulb. Do you feel any difference? That is, make a circuit as shown. Take what we have to take about 10 cm long piece of nichrome wire and tie it between the, that is, we are taking two nails and we have to tie the nichrome wire between the two nails, or you can use a piece of discarded coil or an electric heater. Touch the wire. Now switch on the current in the circuit by moving the switch in the on position. After a few seconds, touch the wire. Do not hold it for a long time. Switch off the current. Touch the wire again after a few minutes. The wire gets hot when an electric current passes through it. It is the heating effect of the electric current. That is, the wire gets hot. It is due to the heating effect of the electric current. That is, you might have seen electric room heater on electric heater used for cooking. All this contain a coil of wire. We can see that. This coil of wire, it is called an element. So it is oil is represented as an element. Notice that with this appliance are switched on. Bujo could not see the element in an electric iron. Paheli told him that electric appliances such as immersion heaters, hot plates, irons, geysers, Electric kettles, hair dryers have elements inside them. In an appliance, we have seen in certain equipments we can see here. After connecting to the electric supply, the elements become red hot and give out heat. Amount of heat produced in a wire. What it depends on? Depends upon the material length and thickness. This for different requirements, the wires of different materials, different length and different thickness are used. Wires used for making electric circuits do not normally become hot. On the other hand, the elements of some electrical appliances become so hot that they are easily visible. That is, incandescent electric bulbs are often used for lighting, but they also give heat. It means that a part of electricity consumed it is used for producing heat. It is not desirable as it results in the wastage of electricity. The fluorescent tube lights and compact fluorescent lamps are better electrically efficient lighting sources. Nowadays, the use of light emitting diode, that is LED, bulb is increasing. For producing a given intensity of light, LED bulbs consume less electricity as compared as incandescent bulbs or fluorescent tubes or CFLs. Thus, LED bulbs are much electricity efficient and therefore being preferred. It is advised to use electrical appliances and gadgets which are electricity efficient. Bureau of Indian Standard, that is ACMARC, ISI, is an assurance of conformity to a specification given on the product. It is therefore suggested to use ISI mark products. Fluorescent tubes, CFLs, and mercury water that is toxic in nature. Therefore, damaged fluorescent tubes and CFLs need to be disposed of safely. It is an electric bulb get heated to glow a high temperature, then it starts glowing. If an electric current passes through a wire, the wire may become so hot that it may even melt and break. But it is possible for a wire. Is it possible? No, it's not possible for a wire to melt and break. Make the circuit we used for inactivity. However, replace the cell with a battery of 4 cells. Also, in place of nichrome wire, tie a thin strand of steel wood. Steel wool means it is available for cleaning utensils. If there are any fan in the room, switch off them. Now pass the current through the circuit for some time. Observe the strand of steel wool carefully. Note what happens. Does the strand of steel wool melt and break? Wires made from some special materials melt quickly and break when a large electric current is passed through them. This wire is used for making electric fuses. Fuses used in electrical appliances. Building fuses are inserted in all electrical circuits. There is a maximum limit on the current which can safely flow through the circuit. If by accident the electric current exceeds the safe limit, the wires may become overheated and may cause fire. If a proper fuse is there in the circuit, it will blow off and break the circuit. Caution: never try to investigate an electric fuse connected to the mains. Visit an electric repair shop and compare the burned fuse with the new ones. So if you are going to the electric shop, we can distinguish between a burned one and the new fuse one. One reason for excessive current in the electrical circuit is the direct touching of wires. This may happen if the insulation of the wires has become off due to wear and tear. This may cause a short circuit. Another reason for excessive current can be the connection of many devices. That is, many devices has been connected to a single socket. This may cause overload of the circuit, and you might have read reports in newspapers also about this overloads and short circuits. Miniature circuit breaker, that is MCB. These days, miniature circuit breakers are increasingly being used in place of fuses. Nowadays, we are using MCB in the place of fuses. These are switches which automatically turn off when the current exceeds the safe limit. So when the current in the circuit exceeds the safe limit, it automatically switch off. You turn them on and circuit is once again complete. Caution: always use proper fuses which have been specified for particular applications. Carrying the ISI marker, never use such just any wire or strip of metal in the place of a fuse. Fuses of different kinds are used for the purpose. Shows fuses used in houses. Fuses shown is generally used in electrical appliances. Heating effect of the electrical line, and learn that is how we use it as advantage. Magnetic effect of electric current. Take the cardboard tray from inside of the discarded matchbox. Wrap an electric wire a few times around the cardboard tray. Place a compass needle inside it. Now connect the free ends of the wire to an electric cell. Note the direction in which the compass needle is pointing. Bring a bar magnet near the compass needle. Observe what happens. Now watch carefully the compass needle. It is smooth to switch on the position. What do you observe? Does the compass needle deflect? Move the switch back to the off position. Does the compass needle come back to the initial position? Repeat the experiment few times. We know that the needle of the compass of a tiny magnet which points in north-south direction. When we bring a magnet close to it, the needle gets deflected. We have also seen that the compass needle gets deflected when the current flows in a nearby wire. Can you connect this to observation? It is called as what Hans Christian Ørsted. He was the first person who noticed the deflection of the compass needle every time the current was passed through the wire. So when the electric current passes through the wire, it behaves like a magnet. This is a magnetic effect of electric current. In fact, an electric current can be used to make a magnet. And let us try it out. Remember not to switch on the current for more than a few seconds at a time. The electromagnet weakens the cell quickly if left connected. Take around 75 cm long piece of insulated flexible wire. Flexible wire and iron nail, say about 6 to 10 cm long. Wind the wire tightly around the nail in the form of a coil. So we have to tie it with the nail in the form of a coil. Connect the free ends of the wire to the terminals of the cell through a switch, a short. Place some pins on or near the end of the nail. Now switch on the current. Do the pins cling to the tips of the nail? Switch off the current. Are the pins still clinging to the end of the nail? The coil in the above activity behaves as a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism, and it is called electromagnets. Electromagnet can be made very strong and lift heavy loads. The end of such a crane has a strong electromagnet attached to it. Electromagnets are used to separate magnetic material from the junk magnet. That is, doctors use tiny electromagnet for the purpose of removing the glass from the electromagnetic that has been stuck in the ice during the accident cases. Many toys also have electromagnet inside them. Electric bell. We are quite familiar with the electric bell. It is an electromagnet in it. Let us see how it works. Shows the current of an electric bell. Consisted of a coil of wire bonded on an iron piece. Coil acts as an electromagnet. An iron strip with a hammer at one end, it is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil and becomes an electromagnet. It then pulls the iron strip in the process of hammer Hammer at the end of the strip strikes the going of the bell to produce the electromagnet plus the iron strip. As the electromagnet pulls the iron strip, it also breaks the circuit. Flows to the coil, stops flowing. The coil is no longer an electromagnet. If no longer attracts the iron strip comes back to the original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes gone again, and it is repeated in a quick suction. That's all about this chapter. If you are interested, please do like, share and subscribe my channel. Okay, thank you.